I am on page 66 of the textbook, and we are talking about combinations. We talked about permutations, which is a mixture, a selection of objects where order is important. With combinations, we're looking at a selection of objects or values in which order is not important. So if you need to pause the video to get that definition, that's fine. But let's take a look at a story. And I'm going to tell you the story in my own words. Okay? Let's suppose that we are at the airport, or that people are at the airport, and here is a shuttle bus that goes to pick up passengers. So you have 1, 2, 3, 4 seats filled. Here's the driver. Okay. And there are 2 empty seats on the shuttle. So these blue ones are the empty ones. There are 2 empty seats. So the shuttle pulls up at a stop, and there are 4 passengers waiting to get on the shuttle. So let me draw those for you. And I'm going to just make them all circles. And we're going to call these 4 people A. So we'll say that's Adams, Bennett, Clark, and Davis. So these 4 people want to get on that shuttle, but there are only 2 seats available. So we could let Adams and Bennett get on. That would be fine. We could let Bennett and Clark get on. Or we could let Clark and Davis get on. Or we could let Adams and Davis get on. So you see how I'm making those combinations for the people to fill these 2 seats. Okay, so that's the story that we're trying to figure out. The question that we're trying to answer is how many ways can the 2 passengers be chosen? And I've already done some of that. I said Adams and Bennett, Bennett and Clark, Clark and Davis. How many ways could we mix them up? And so to do this one, I'm going to draw a tree diagram to begin with, and then I'll show you the mathematical way. But let's put this in a very clear picture. All right, so here come the first passengers. And I'm just going to copy them and paste them down here and rearrange everybody. Okay, so I'm going to say, all right, let's all line up here. And I'm going to just pick, or the bus driver's going to pick one of these people to get on the bus. So let's say that he says, okay, Adams, you're going to get on the bus. So Adams is on the bus, leaving these 3 behind. All right. So let's say that Adams gets a seat. So we're going to take Adams out of the mix. He's on the bus. Who is left for the second set of passengers? We've taken Adams out, so it's not Adams. It could be Bennett. It could be Clark. Or it could be Davis. So any one of those combinations would work. Adams and Bennett, Adams and Clark, or Adams and Davis. All right, let's go ahead while we're here and put those in order. So Adams and Bennett could get on. Adams and Clark, or Adams and Davis. All right, what if Bennett is the first one on the bus? Then what would the situation be? So Bennett's already on the bus. So Adams could be the second person. Clark could be the second person, or Davis could be the second person. So it could be Bennett and Adams, Bennett and Clark, Bennett and Davis. So BA, BC, and BD. Okay, that would work. What if Clark is the first person on the bus? All right, so Clark is the first one on. We're going to take him out of this picture. So then we could have Clark and Adams, Clark and Bennett, or Clark and Davis. Hopefully this is getting a little bit simpler in your mind, at least what I'm doing. And then if Davis got on the bus first, we're going to take him out of the mix. And we're left with Adams as the potential second seat, Bennett, and then Clark. So any of those could be the second one. And I forgot to do this, didn't I? So we have Davis and then Adams, Davis and Bennett, Davis and Clark. And then here we have Clark and Adams, Clark and Bennett, Clark and Davis. And then those I did. So there's the tree diagram that represents this situation. And these are all the possible ways that the people could get on the bus. All right, now we need to look at another concept called, what made that go blurry all of a sudden? Called a redundancy. And a redundancy simply means that they're in there twice. They're duplicated. So, would you agree with me that this value and this value are redundant? Adams and Bennett, or Bennett and Adams, represent the same two people. One of those is redundant, so I need to remove one because order doesn't matter. It doesn't matter if Adams steps up first or Bennett, both of them get on the bus. So I'm going to remove one of them, and I'm going to do it right here. Okay, so we still have Adam and Bennett. We have them right there. I just removed the redundancy. Okay, here I have Adams and Clark. And down here I have Clark and Adams. So one of those is redundant. And I'm going to remove one of them. Doesn't matter which one because it's the same two people. All right, and then I have Adams and Davis. Well, that's the same as Davis and Adams down here. So let's remove that redundancy. Then I have Bennett and Clark, which is the same as Clark and Bennett. So let's remove that one. Bennett and Davis is the same as Davis and Bennett. So I'll remove that one. And then Clark and Davis is the same as Davis and Clark. So I'll remove that one. So now I'm down to only 6 possibilities or combinations of people who get on the bus. So to answer the question, there are 6 combinations. After you remove the redundancies. I'm going to write that just a little bit bigger. Redundancies are duplicates. Because order doesn't matter. So there are 6 possible combinations. All right, I'm going to go ahead and show you the formula that goes with this type of math. And this is coming into page 67. So I'm just going to add that we are moving into 67 up here. So here's the formula that you will need to know. And I'm going to move this picture right over here. We're still working with that example, but let's do the formula this time. So to do this, I'm going to change colors. Let me get a different, let's do green. All right, so here is the formula for combinations. C of NK, that looked familiar, equals P of NK over K factorial. Okay, that looks horrible. I will agree that it looks horrible. And yes, the calculator will do it for you. But let me show you what this formula means, how it's derived and what all of that means. So C is going to be the number of combinations. So in our question, that is 6. All right. P is going to be the number of permutations. N is going to be the number of passengers in this case. And K is going to be the number of ways the passengers can be selected. So let's set up this formula and see what we get mathematically. So we have combination. There are 4 passengers waiting to board. There are Adams, Bennett, Clark, and Davis. That's 4 people. And there are how many seats available on the bus? There are only 2 seats available. All right, so then we're going to have to take the permutation of 4 and 2 and divide that by 2 factorial. So all I've done there is to substitute my values into my formula. Order doesn't matter. So we are going to not have to worry about who gets on first, who gets on second. We're just going to do this according to the formula. So the combinations will be, and I'm going to use my calculator to get the permutation of 4 and 2. So I will do all clear, 4, shift 1, 2 equals, that's 12. Okay, that was the number before I removed the duplicates. So permutation is going to be the number before the duplicates are removed. Okay. But I would just use the calculator to find that. And then 2 factorial is going to be all clear, 2 shift 3. And that is 2. combinations equals 6. That is the number after the redundancies removed. We're going to practice this. I know it's complicated. I just wanted you to see how the formula is derived. Okay. All right, to do this problem on your calculator, here's how you would do it. So let me change color again. I think I'll use this violet color. And I'm going to need some calculator keys. So let me just make a copy of this one. And I think what I'm going to do before I move us into any word problems, I want to give us a chance to just practice the formulas. So I'm going to find some examples online and just put those in to practice the formulas. But here's what we're going to do. We're going to do the combination of the number of passengers here, that's 4, Adams, Bennett, Clark, and Davis. And then the number of seats available are just 2. So let's put this in the calculator. All clear. The N value is 4. And then you will press Shift, the number 2, and then put in the 2 that's in parentheses up there. So let me hold up 1 second. And then the last thing we'll press is equals. So this 4 is the N value. And this 2 right here, the second one, is the K value. And when you press equals, you should get 6. I got lost. Let me start again. So all clear, the N value, Shift, digit 2, then the K value equals 6. And that will be the number after the redundancies are removed. Okay, I'm going to stop this video and find us some more examples, and then we'll come back and finish this page eventually. But I want to practice these before we do that.